Hello, this is Mercy from ACEC. My roll number is J1. Today my seminar topic is programmable logic devices, which are known as PLDs. Let us discuss about the PLDs. What are PLDs? How are they used? And what are the different types of PLDs? And moreover, what type of PLDs we use for the logic devices. Let us start with the introduction. What is PLD? Programmable logic devices, which are known as PLDs, are digital integrated circuits that can be programmed to implement various logic functions. So, PLDs are used for creating any digital logic circuit. For example, if we wanted to create a digital logic circuit, PLDs are very used to form any kind of we can form any kind of logic circuits for our convenience. So they provide flexibility in digital circuit designs without changing the physical hardware, without changing the gates, or without changing the circuit. We can provide flexibility, like we can change any type of a parameter or something in the uh, digital circuit. This PLD consists of gate arrays, flip-flops, resistors, etc. It contains many of the components. So these are reprogrammable devices. PLDs can be reprogrammed at any time, at any circuit. So there are three classifications in PLDs. Number one, simple programmable logic devices, which are known as SPLDs. Two, complex programmable logic devices, known as CPLDs. Number three, field programmable gate arrays, FPGAs. So these PLDs are divided into these three types. So let us see what are the three one by one. So number one, in SPLDs we have um, three types of devices. Number one, programmable read-only memory. Next, PLA, programmable logic arrays. PAL, complex programmable logic device. So these are the three PLDs which are present in SPLDs. So let us see what are these, how are they used, and their logic diagrams. So what are the components we use in them? So coming to the PROM, which is also known as programmable read-only memory. This PROM consists of a fixed AND gate array and programmable OR gate array, which means that this AND gate array is fixed. It is not changeable, and OR gate array is programmed at any time. So we can program, or we can recreate the OR gate array, but we cannot change. There will not be a change in the AND gate array. So this is used in implementing combinational logic circuits, as we know, and if this is programmed once, it cannot be reprogrammed. While creating the PROM, we have to take measures so that it is not reprogrammed again, and it is one type of a read-only memory. And by using this PROM, the user, or the one who created the circuit, can implement the Boolean function, which must be in SOP, and there will not be a don't cares which are without. The AND gate array in PROM appears in terms of decoder. So as we know what are decoders, the AND gate array in PROM that appears as decoder, and the variables of Boolean function acts as the inputs of the decoder. So the variable which we give in the input, they act as the decoders. So the Boolean function output are equal to number of OR gates. So um, how can we know that the PROM is being activated? That the Boolean function output, which it will be equal to the number of OR gates which we have taken. Coming to the second one, PLA, programmable logic array. In this programmable logic array, AND gate array and or get array, both are programmable. So we can change them, or it can be reprogrammed again at any time. Next, the flexibility of the circuit. Flexibility, which is means that we can rechange the program, or we can arrange it in a different ways. It can be implemented by using PLA is more reliable, or more user point of view. Uh, According to the user, it will be very useful to rechange or reprogram the arrays. So it is used in medium complexity logical applications. It is not used for combinational circuits. And by using PLA, the user can implement the Boolean function, which must be in standard SOP. Coming to the third one, PAL, programmable array logic. In this programmable array logic, AND gate is fixed, and AND gate is programmable and OR gate is fixed. So it is much way simpler than PLA. So because programmable of AND gate is way easier than the OR gate. So it is very easy than PLA, and it operates faster than PLA, and we can realize any Boolean function by using PAL, but the function must be in the form of sum of products, which is SOP. To program PLA by user, first user have to make a programming table. You have to make a programming table for the given Boolean function. After simplification of it, the user have to form a programming table to create a PLA. So this PLA is widely used in control logic applications. So coming to the second type of PLD, complex programmable logic devices, CPLDs. These CPLDs are used to combine multiple SPLDs on a single chip. As we have learned the multiple SPLDs, which are PROM, PLA and PAL, it is used to combine these three in a single chip, and it provides moderate logic capacity, and each block contains interconnections which are programmable. Each block we can program them in every block, so we can program as the user's option. So this is the introduction of complex programmable logic. Coming to the third type of PLD, field programmable gate arrays, FPGAs. So this contains configurable logic blocks, CLBs, and interconnections between the circuits. It is used for high performance and complex digital designs, and it can be reprogrammed multiple times. As we have seen the before PLDs, they can be programmed or twice or thrice or sometimes, but it can be multiplied. It can be reprogrammed many times, as many times as possible. This is the advantage in FPGAs. Coming to the differences of the SPLDs, SPLDs has PROM, PAL, PLA. So let us see the differences. For PROM, AND gate array is fixed and OR gate array is programmable. For PLA, both AND gate and OR gate are programmable. For PAL, OR gate array is programmable, OR gate array is fixed and AND gate array is programmable. Next, PROM is cheaper and simple to use. PLA is costlier, and it is way costlier and complex than PAL and PROMs. And PAL is also cheaper and simpler. So by making the difference, PROM and PAL are used more often than PLA, because PLA contains the components which are way costlier, and all minterms are decoded. In PROM, all minterms are decoded, and in PLA, an array can be programmed to get desired minterms. In PAL, AND gate array can be programmed to get desired minterms. Next, in PROM, only Boolean functions in standard SOP can be implemented using PROM. In PLA, any Boolean functions in SOP form can be implemented using PLA. And in PAL, Any Boolean functions in SOP can be implemented using PLDs. So there are way more differences in these three. These are some points of it. So let us see another point, which are for PROM, design flexibility is less. For PLA, design flexibility is a moderate, and for PAL, design flexibility is more. So these are the differences for the SPLDs from PAL and PLA. So these are the logic diagrams, and for PROM this is the logic diagram which we used a 3x8 decoder, which we have taken 3 inputs and given 7 outputs, 8 outputs, which are M0, M1, M2, M3, M4, M5, M6 and M7. So by implementing this we get 2 outputs. And this is the logic diagram of PLA, which we have 3 inputs, and we have taken OR gates and given as 2 outputs. And this is the third logic diagram of PAL, which is again given as 3 inputs, and the third input is Cin, which is used, which we can keep, which we can be programmable, and we are getting the outputs 2. And this is the logic gates of the 3 PROMs, PAL and PLA. Now these are the examples of different types of PLDs: SPLD 22V10 GL, PAL 116L8, and CPLD we use Altera Max 7000 and FPGAs Intel Cyclone, etc. These are the examples. And applications: these are used in digital signal processing for control systems, radar systems, etc. As they are used in control systems, embedded designs, and communication systems as automotive, electronics and industrial automation, etc. So the advantages and disadvantages of PLDs. The advantages are they are flexible and they are reprogrammable design, which are and they are reduced prototyping time, suitable for rapid development and testing. And some PLDs, they are less cost, cheap, and they are used in a they are very useful. And their disadvantages are, some of them are high cost for small scale production, requires special design tools, which are way costlier and which are more difficult to get, complex programmable for advanced PLDs. So the last conclusion of the PLDs are, the PLDs have revolutionized digital design. They bridge the gap between fixed logic and fully custom ICs, and used widely from small control circuits to complex systems. So we can design PLDs for small complex designs to higher, like combinational circuits and etc. So this is the introduction and the types and the examples, advantages, disadvantages of PLDs. Thank you.